Olá a todos, hello everyone. E se você quiser assistir a versão em português desse vídeo, o link vai estar na descrição aqui embaixo. So these are the photovoltaic solar panels. I know this by far is the most technological and expensive test that we're doing here. But at the same time, number one, this is a technology that's getting increasingly cheaper. And number two, I've seen already a few of these tossed in the trash because people are just changing the solar panels, either because of efficiency or because of aesthetics. So since throughout time, this is a technology that's going to be increasingly cheaper, and also you'll be able to get this from trash and use in your place, and it's going to be 100% working and stuff like this. So for this project specifically, so I could maintain the cost very, very low, I'm only using two full panels, and also I am connected to the grid, so throughout the day I produce energy, electric energy, and send to the company that provides me with electric power, and hopefully the sum between what I produce, and which would be negative in this equation, and what I consume is going to be zero, and I only have to pay 30 to 50 reais here in Brazil for the usage of their system. Another cool thing is those two solar panels are enough for this entire house based on some math that we did, so it's working so far. And another piece of this is the inverter that converts the DC power that the panels produce to AC, and those are underneath the panels, and this is what I'm going to check next. So this is the inverter right here. Each inverter for this specific company that produces these inverters and the solar panels, it takes one inverter for two solar panel photovoltaic plates. So if I wanted to put like an extra two, I would need a second inverter, and so on. I don't know if it's able to see here, but every 10 seconds there's a green light that blinks here, and this indicates that the system is functioning, it's up and running, so on and so forth. When the light changes colors or blinks in a different ratio, it means that there's some problem going on. So this is the inverter. Those are the cables that send the energy down to the house. And over here we have the ECU module, and it pretty much tells us how's the production of energy with the two solar panels, with the photovoltaics. As you can see here, we are producing, at this moment, there's a little bit cloudy, we're producing 354 watts, and historically we already produced 1.45 megawatts hour. We only have 001 or one module up and running. That is the inverter that's upstairs, and at the top is just the address for the local access, so we can parse the data directly on the computer. So it's kind of interesting just to keep checking if everything is going according to plan, if you're producing what you expected, so on and so forth. And so over here we have the parsing of the data on the computer, and we can see the data stretched out and can do some math and some stuff. This is from the manufacturer of the system that I'm currently using. This differs from manufacturer to manufacturer, and there are some who even give you only the API, and you have to build how you are going to parse the data from the ECU. So over here we have just a quick summary of everything. There's a little window here on the right side that says how the CO2 offset equivalent is. So it's equivalent to 120 gallons of fossil fuel, 53 trees, and 1066 kilograms of CO2 production on a factory or in industry wise. in the real-time data, we can actually see like how's the day going here. It's kind of bad day overall because we have a lot of clouds going on. But if we move to another day, you see the curve is much more interesting on how the production is going. Of course, this is always going to appear because of trees and the terrain. Sometimes this is clouds as well. Those are clouds. But as you can see, the curve is actually going to differ when we are in when we are in the summer. So as you can see here, the curve is very different. This is the tree that I was talking about. We also can check information by week. It is like this. We can check by month. How's the month going regarding generating electricity? And yearly, you can actually check how's going month by month here. So as you can see, on the October 2019, I managed to get a peak of 74.31 kilowatts hour. So this is just to show that not only you can produce, but you can also get this data. You can do some math and figure out if you're overproducing or underproducing and why, periods of the year, if you want to do something with the extra power that you're outputting, if you need some more solar panels, if it's outperforming or overperforming, or if it's performing according to plan. And yeah, that's about the photovoltaic part of the project.